Good evening. I am Subramaniam, working as assistant professor in SNS Technology at Mechanical Department. In this session, we are going to see about the IC engines and the power plant engineering in the unit, about the 4-stroke and 2-stroke cycles. So, to 4-stroke, 2-stroke cycles, here we have a small recallant. In the 2-stroke cycles, we have every 2 strokes, we can able to get a 1 power stroke. Whereas in the 4-stroke cycles, we get 1 power stroke for every 4 strokes or 2 revolutions only. Here in this 2 strokes, in the 1 revolution, we can able to get 1 power stroke on the 2 strokes. Whereas here for 2 revolutions, we have to get the 1 power stroke in the 4 strokes. So first will be intake stroke where the piston moves from the TDC to BDC, and then the air fuel mixture will be entering into the fuel will be air will be entering into the chamber, whereas fuel will be injected in the through the fuel injector, and when for the second half of the revolution, rotation gives the compression stroke where the combustion takes place, and if combustion takes place, the power of the fuel air fuel has been heated up and burned, which gives in turn as a power stroke, gives the third half revolution of the engine itself, such that it will be hitting and the power stroke will be created where the piston moves from TDC to BDC in a high speed itself. And finally, the fourth half revolution of the stroke itself is the exhaust stroke, where the piston moves from the BDC to TDC, where the gas burned inside the cylinder will be escaping through the exhaust fan. Similarly occurs here, but in one stroke, in one half of the revolution, the fuel will be taken into the cylinder itself, and on the compression stroke itself, when it is being released from the TDC BDC, the air fuel which is entered into the crankshaft will be entering into the cylinder through the other port into the other port. And in the port, it will be so for the second half of the revolution, when the piston moves from the BDC to TDC, it gives the power stroke itself. The power stroke, the gas burned, and it has been converted to the electrical energy, and electrical energy converted to the mechanical energy to rotate the vehicle itself. So this is a recall. And for the DDM path, the key difference between the 2-stroke and 4-stroke engines, we are going to see about what the key difference between the 4-stroke and 2-stroke engines, and also focusing on their operational principles, which strengthens or weakens and their respective uses in the variety of the vehicles and machinery, and also understanding these differences is crucial for selecting the right engine for specific applications. So firstly about the definition, importance and comparison. So definition is that in the 2-stroke engines there will be located as a spark plug will be located, and ports, inlet port and the exit port will be there. Whereas in the 4-stroke engine, fuel injector will be located, and there is an intake valve and exhaust valve, such that the fuel will be injected through the fuel injector, and whereas the air will be supplied separately where the combustion takes place inside the cylinder itself. Here the air fuel mixture both will be mixed in the carburetor, and the air fuel mixture will be put in the 2-stroke engine itself. So comparison we say the 2-stroke engine, every 2 strokes or every 1 revolution can able to get 1 power stroke. Here every 4 strokes or every 2 revolutions can able to get the power stroke itself. This is one of the 4-stroke engines. So in detail we see about the 4-stroke engines. Already informed you, there will be as an intake stroke where air will be let inside the cylinder itself, inside cylinder to a certain level, when the engine moves from the TDC to BDC. And when it rotates the second half of the revolution, it will be compressed on the inside the air fuel mixture will be compressed when the fuel has been injected into the cylinder itself, and there's a power stroke will be getting. In the power stroke, it will be hit the piston from the TDC BDC, and where this was the power stroke, and the last half of the revolution, there is the fourth half of the revolution, the piston moves from the BDC to TDC, such that the burn gas has been escaping outside. Whereas in 2-stroke is the same model itself, but it will be when it moves 1 stroke itself, the air fluid will be entering into the crankshaft, and when the piston moves from the after exhausting the exhaust valve, it moves from the TDC to BDC. The air fluid which is inside the crankshaft will be moving to the cylinder itself. And this is a comparison between the 2-stroke and 4-stroke. So merits one power stroke will be in one revolution, whereas demerits here the one power stroke is in 2 revolutions only. Power generated for the same generation speed theoretically twice as the for the 4-stroke engine. Power generated is the same theoretically half of the 2 revolutions. And we see merits, and here the starting is easy, whereas starting is not as easy, and desired port is simpler. Here desired valve mechanism is more difficult. Okay, with this will come to the end of the session of completing the 2-stroke and 4-stroke engines. For reference, it has been given here. So this one is when the gas have been burned out gases as known as scavenging, and transfer port is available in the 4-stroke engines. This is the 2-stroke engine only. Thank you. This we will have the reference also. Thank you for seeing this video.